char, and there's an array here. And what does that say? Dakota?
Exactly the same thing as the first.
Exactly the same as this one. There's a little bit of syntax difference. What is it?
You initialize the STD string length.
What is this? As far as I can tell, there's just this part is different, right? What is that? Tyler?
I'm not entirely sure. I know it's pointing, or it's telling you that that functions from the standard library.
It's exactly right. Now, up here,
Oh, because you told us to use
we
our
said,
version.
pardon me?
Because you told us to use our version of string length.
String, well, actually I didn't. String compare, yes.
Oh, sorry.
Not string length. But up here we see this, a similar notation. And this is what we call an example of a namespace. A namespace. Using refers to a namespace, or is qualified by a namespace. And it resolves exactly that problem, Dakota. That if I write my own, and Justin writes his, he calls his string length also. And Jeff, you write yours and you call yours string length. And I've got all three of them available, and all three are different. Justin uses one that counts null as part of the length of the string. Jeff says, I'm going to do it one less than the actual number of characters. And Dakota does one that actually counts the number of characters. All three are different result, right? Three different functions. How do I distinguish between them? Well, I can declare, Jeff will say, I'm going to create a namespace called Jeff. And things that are defined within that namespace can be prefixed, qualified with Jeff. Jeff : string length. Justin will do the same thing. He'll create a namespace called Justin, and he'll say Justin : string length to get his. And Dakota will say Dakota : string length. Is that clear? It's a namespace. It's a feature that we use. You'll come across it more in depth in 136. STD is the standard namespace that is predefined for you by the compiler writer. Refers to the standard library for C++. And that's why we do this using. We say we're going to use, whenever you see CN, you're going to use the one from the standard library. Whenever you see endline, you're going to use the one from the standard library. I put this in here to make a point. Sometimes I require you to qualify all of those standard functions. You could, notice that up here we said using std:"cn". Instead of doing that, we could have left that off, and any place in here, I don't think there isn't any place where we read something, but we could, every place we wanted to use CN, we could leave this using off altogether. Guess I better undo. We could leave this off, this line off altogether, and any place I had CN, I could just simply qualify it saying std:"cn". Is that clear? The using says, in this compilation unit, this file, I'm going to, whenever you see CN, assume it to be std:"cn". Clear? Questions? Okay. So that's, again, I'm just making a point here of specifying the standard string length and the standard string copy. Everybody's clear as to why I cannot say pointer chars equals chars. But I have to do the string copy. Does anybody have any question about that? In other words, will that compile? Will that compile? Yep, Daniel, it will compile. Will it work? Will it do what I want?
No.
What's going to happen?
Copy the address.
Just copies the address. It's what we call a shallow copy. A shallow copy. So, unlike this one says, okay, yeah, pointer chars is a pointer to a character string. So we'll give it the address of the constant, right, or whatever it was up above. Chars, we'll give it this address. Copy the address of out in there. And so when we do that, we're just copying this address over to here. This thing does not point to this memory. Is that clear? So when we try to delete down below, delete square bracket pointer chars, we're going to crash because you can't delete a static variable. Clear? Sometimes we want to do this. Most of the time we don't. This is called a shallow copy. Therefore, since that's a shallow copy, what do you suppose that one is? It's called a deep copy. A deep copy. This high-tech terminology, Dwight, I know it's really confusing, hard to remember. What does that word mean? But there it is. We just have to deal with it. Okay? What does this do? It is so complicated, it is so hard, so difficult. What does it do? There's a lot of code buried there, a lot of things going on in one very simple line. What does it do? Max?
Yeah, I'm trying to figure out what those pointers are pointing to, but it's deallocating it in a way.
Deallocating? No,
Sorry,
deallocation.
no, I'm using the wrong terminology.
No deletes
It's
there. Jeff?
dereferencing. That's
Dereferencing, yes, okay.
And then adding one to it.
Adding one to what?
It's comparing whatever's inside of it.
What
It's a
does the
character
plus
or
plus affect?
the value.
What is it an argument for?
Oh, right.
It's incrementing the pointer. So the first thing we do here is splat, dereference this pointer. Okay, that's interesting. All right, and then after we've dereferenced it, what's the order of operations here? What do we do next?